First, a high-level comment on the carry trade. The carry trade is a strategy for making money in the currency markets. And how does this strategy work? Obviously, there are some assumptions involved, but simplistically, I will give you a scenario and then I will give you all the technical jargon. But first, understand the big picture. Let's say that you are in a city with two banks. One bank is called the dollar bank, and there is another bank called the rupee bank. The dollar bank says that the interest rate, whether you lend or borrow, is 1%. The rupee bank says that the interest rate, whether you lend or borrow, is 10%. This city also happens to have a money changer, and the spot rate is currently 100 rupees to the dollar at time 0. Now, you do your economic analysis and you just look at these numbers. You say dollar 1%, rupee 10%, 10% looks much more than 1%. So let me try to make some money over here. So you go to the dollar bank and you borrow $100 million and you put those $100 million in your armored vehicle and you go to the money changer with lots of briefcases of dollars. This is a 1-year loan that you've taken out and the interest rate that you've agreed upon is 1%. That means after 1 year, you will return 100 million plus the 1% interest rate. You go to the money changer and how many rupees do you get? So you get a 100 million or essentially 10 billion rupees. So now you take a bunch of more armored vehicles times 10 and your convoy then goes to the rupee bank. So why do you think it's called the carry trade? Because you are carrying these dollars from here to the money changer and then you are carrying the rupees to the rupee bank. So you deposit your 10,000 million or 10 billion rupees over here. And what happens 1 year later? You get a 10% return and you now have rupees 11 billion after 1 year. If your currency forecast was correct and the exchange rate has not changed, then what will you do? You will take this 11 billion rupees, go back to the money changer, convert into dollars. So how many dollars will you now have? You will have 11 billion divided by 100. So you will have 110 million dollars. Now you get rid of some of your extra trucks and in your one truck you go back here and what do? You pay him back 100 million plus the 1% and you keep the rest. 9 million. So that is a carry trade transaction. I don't know why they call it carry trade, but this is the reason that I invented for the name behind the carry trade, because you are carrying lots of money back and forth. Okay, here's a more formal explanation that you will see in the regular video. The carry trade assumes that uncovered interest rate parity does not hold. Why? Because if uncovered interest rate parity holds, then obviously the rupee would devalue. You started out at time 0 with an exchange rate of 100. And if 1 year later the rupee has devalued by 10% or more, then so much for your bright idea. So that idea of the carry trade assumes that at least in the short run, or when you are doing these transactions, or when you are conducting, or the time frame for your trade, during that time frame, the uncovered interest rate parity does not hold. That's what you're assuming. So I'll take this and I'll say that carry trade assumes this doesn't hold. Is that true? Now it depends. It depends. Here I've actually picked out the rupee per dollar exchange rates from early 2000 to 2012. And notice that in this period between 2002 and 2008, the exchange rate was fairly stable, around 60. Do you remember that? Yes. So if you had done the carry trade transaction from here to here, would it have worked? Yes. Then if you had done it again from here to here, would it have worked? Yes. And then from here to here? Yeah, but then what would happen from here to here? Huge loss, right? All the money that you made here would be lost, because by this time you are so excited about your genius that you have multiplied by 10 the amount of money that you are investing in this, and all gone, or at least a lot of it is gone. So the point is, it can work, but there is no guarantee. If there were guarantees in finance, then there'd be some people who just make a lot of money and not teach any of this stuff. What's involved here? FX carry trade. Now I'm using the formal terminology, and you will notice that all this will connect with my somewhat humorous example. You are taking a long position in the high yield currency. In my example, what was the high yield currency? The rupee was the high yield currency. What does a long position mean? that you are buying rupees and you are essentially, your investment is in rupees, and you take a short position in the low yield currency. What does that mean? That you actually, what you have done is you essentially borrowed the dollars and then you sold dollars to get rupees. So you have taken a short position in the low yield currency, which is the dollar. In other words, remember, the interest rate that you are paying is the 1% rate on the dollar. The interest rate that you are getting is the 10% rate on your long currency, which is the rupee. Generally, carry trade transactions are characterized by many small gains, and as you might see over here, a few large losses. So you can get lucky, but this can also happen. When you have the large loss, what's that called? It's a crash. What's the risk of that happening called? Crash risk. When you think about it, all this terminology has some logic behind it. If you can remember that logic, then it will serve you well on the exam. Let's see if you can understand this terminology. A carry trade is a leveraged position. Why do we say that? You are borrowing money, so you borrow money in the funding currency. What's the funding currency? The funding currency is the dollar, and you invest it in the high yield currency. And as you studied at level 1, whenever your transactions involve a lot of leverage, what does that do to your gains and losses? It magnifies the gains and losses. Now that you are experts on the subject of the carry trade, let's work through example 8. A currency fund manager is considering allocating a portion of her FX portfolio to carry trade strategies. The investment committee asks the manager a number of questions about why she has chosen to become involved in FX carry trades and how she will manage the risk of potentially large downside moves associated with the unwinding of carry trades. Which of the following would be her best response to the investment committee's questions? Carry trades can be profitable when covered interest rate parity does not hold, uncovered interest rate parity does not hold. So we've just done this. That's the correct answer. Over time, the return distribution of the FX trades is most likely to resemble, and now what does this connect with? This connects with level 1 quant. Do you think your distribution is a nice symmetric normal curve? Or is it a distribution with fat tails and a negative skew? What does negative skew mean? Negative skew means that you have something like this. When you have losses, you have big fat losses. So the distribution then is fat tails, negative skew. So what's the correct answer here? B. The volatility of the fund's return relative to its equity base. In other words, do you think the volatility is relatively high or relatively low? The volatility is high. What explains that relatively high volatility? Leverage. So notice that all the concepts are fairly straightforward. Next. Which of these risk management strategies is most likely to reduce some of the negative tail risk associated with FX carry trades? And here just try to use some common sense. If we use forward contracts, then are we going to make any money beyond the risk-free rate? No, then it would not really be a carry trade, because then you are just locking in a certain return. What if you exit the carry trade position when the implied FX volatility drops below a certain threshold? When the volatility of the currency pair becomes less, is that a risky sign? Or when the volatility goes up, is that a risky sign? Goes up. What's happening here? Volatility is going down. So is this a risky sign? No. So it's not a risky sign. So this doesn't look like the appropriate answer either. Exit the carry trade when the funding currency, in our example, what's the funding currency? Dollar. If the dollar drops below its PPP level, in other words, the dollar is now undervalued. So you are looking at all this inflation data, and based on that, you are quite convinced that the dollar is undervalued. If the dollar is currently undervalued, what do you think will happen? It will go up. And if the dollar goes up, that messes up your grand plan. So the moment you sense that might happen, what do? You close out, you exit. So that is the answer. Okay, now if you've understood what I'm talking about, then you have to do question 5. And there can't be a case here without some numbers. And here actually you need to calculate. So let's see who can do this. You are a Tokyo-based asset manager. So I would just suggest and recommend that you start with yen. And for simplicity, so that we are aligned when I do the calculations later, let's say that you start with 100 yen. And then you go through these carry trade transactions. Given that our answer is in percentage terms, whether you do 100 or 100 million, the answer should be the same. We are dealing with yen and Australian dollars. Do we have an exchange rate for yen and dollars? No. So what's the first thing that we need to do? So this question is making you do a lot of work. What's the first step? You need to figure out the Japanese yen to Australian dollar exchange rate. And what's that going to be? That's going to be the Japanese yen divided by USD multiplied by USD over Australian dollar. Conveniently for us, we have numbers in this convention. Generally, cricket playing countries tend to be base currency. What's the Japanese yen to USD? So the spot rate today, Japanese yen to USD is 81.3. Multiplied by USD to Australian dollar. What's the spot rate? 1.0750. So what is the spot rate today? Let's say it is, let's use the proper convention. How many decimal places do you think we should have here? Actually, when you have the yen involved, then you will have 2 decimal places. So let's say it is 87.397. So 2 decimal places means it is 0.40. Then what happens? So that's at time 0. Which is your low yield currency and which is your high yield currency? The Japanese yen is your low yield currency. When you came up with this 100 yen, what did you do? Did you borrow? So you borrowed, let me draw it like this. So you borrowed your 100 yen at an interest rate of 0.1%. That's your borrowing. You then converted that into Australian dollars. So how many Australian dollars do you have? So here is the conversion and you have 87.40. And then you invest these Australian dollars. So this is Australian dollar. At what rate do you invest this money? The Australian dollar is your high yield currency. What's the rate over here? 4.5%. So how much money will you have over here? So that's the exchange rate. I need to actually divide this by 87.40. So how many Australian dollars do I have? I should have 1.144. That's how many Australian dollars I have at what time? At time 0 when we start. This is invested at 4.5%. So after 1 year, how much will I have in Australian dollars? 1.1957. That's how much money I have in Australian dollars after 1 year. Then what do? Then I convert that back into yen. So what's the rate that I now use? So based on these spot rates, I use a rate of 86.42 and I get how many yen? I get 100.33 roughly. So this is the amount of yen I have at time t equal to 1. Then what do? Why is this answer 103? So what's my return? 3.33%. I still need to return. Remember, I borrowed money at 0.1%. So I go back to the original Japanese yen bank and I need to pay back 100 plus the interest, which is 0.1%. So from 3.33%, I minus 0.1%. So what am I left with? About 3.23%. So that's our correct answer. Question? The question is, where did this 86.42 come in? 86.42 is the exchange rate at time t equal to 1. Given we use the same multiplication, so we are coming up with a cross rate after 1 year. You simply multiply these two numbers together and that will give you the Japanese yen to Australian dollar rate after 1 year. Alright, so somewhat elaborate in the entire session so far. This is the only calculation we've done and I think it's an important calculation.